Hey everybody, Mr. Morel here, woo! And we're going to be talking about homework assignment 4.2, solving systems by graphing, okay? So remember, in class we talked about a system of equation is something that looks like this. It's two equations that kind of go together. And kind of piggybacking off of what we did last worksheet, last video, is that we're trying to find one ordered pair that works with both of the equations. It can be a little tricky. But luckily we have a lot of different ways that we can do this, and one of the ways is by graphing. And graphing can be pretty easy. So let's go ahead and start with these level 1 questions. So our job, let's read these instructions here because reading is good. Below you'll be given two equations and a graph of two lines. We need to label A or B. Oh, each is labeled A or B, so the lines have a label, that's all that's saying. You need to say if each equation is line A or line B, and write the ordered pair where the two lines intersect. So let's start by doing that first part first. We have this line here, and it's line A. And we need to figure out which one of these equations is line A. Okay? Well, to me it's always easier just to look at the y-intercept. There's the y-intercept at 2. This has a y-intercept of -2, but this one right here has a y-intercept of +2. So that one there is line A. And just to double check, in theory this other line has a y-intercept at -2, and it sure does. There's line B right there. So easy. And now we need to find out where they intersect. What's this ordered pair here? Well, remember, ordered pairs give your x value first, which is your across way, and then your y value after that. Okay, so it looks like we go to the right one and up one. So the ordered pair where they intersect is 1, 1. Now, just to help you understand why we're doing this and to connect it to the video from before, in theory, this ordered pair right here, 1, 1, is going to work in both of these equations. So let's just test that out. You don't have to do this on your work, but I'm just trying to explain what in the world we're finding. If I plug a 1 in for x and a 1 in for y into both of these equations, let's see what happens. So we're going to have 1 equals 3 times 1 minus 2. 3 times 1 is 3, minus 2, and then 3 minus 2 is 1. And then we could bring this one down. Do you see how we got the same thing on both sides? So we know that 1, 1 is one of the solutions to that equation there. We could do the exact same thing with the other equation just to check. Plug in a 1 for y, -1 times 1 plus 2. Well, -1 times 1 is -1. And then -1 plus 2 is also 1. So we got the same thing there. This is the only pair of numbers that's going to work with both of those equations. Okay, let's go ahead and look at this question 2. Hold on, I have a thing on my screen. Okay, so question 2. Well, let's see, we could go the other way. What if I look at this equation here? It has a y-intercept of -2. Well, this line has a y-intercept of -2, and awesomely, it has a slope of -1/2. So that is line A. This equation down here has a y-intercept of -4. Well, this has a y-intercept of -4, and it has a slope of +1/2. So that one's probably B. Now, we need to figure out where these two are crossing right here. What's that ordered pair? Well, that ordered pair is going to be to the right 2 and down 3. So we would write that 2, -3. Okay? And again, we could double check that by plugging in our x and our y into both of these equations. And, I encourage you to do that if it's going to help you understand. Trust me that that is going to be the right answer. So that I can move on. Alright, let's go down to these level 2 questions. So this time, I'm not giving you the graph, you have to actually create the graph and say where they cross. So it's usually helpful for me, especially where I'm dealing with colors, to kind of designate a color for each line. So the top equation has a y-intercept of 3, and let's just remind you, when we did this back a couple units ago in my videos, it's always easier for me when dealing with equations to work backwards. I start with the y-intercept. Oh my gosh, and I'm glad I said that because holy cow, I made a silly rookie mistake. Remember, this is plus -3. This y-intercept of this red line needs to be at -3. Woo! Good thing I caught myself. Okay, and then this number right here is our slope. It has an invisible 1 under it. That means that we need to go up 3 and to the right 1 to find our next point. Up 3 to the right 1, up 3 to the right 1, or we could have gone down 3 and back 1 to continue that line. Here's the line like that. Okay, let's go ahead and do the green line. So the green line has a y-intercept of positive 2, and it's going to go up 1 and to the right 2. So we're going to do that, and we need to draw in the whole line because we want to show the entire line for that equation. It's going to look like that. Now the last part is to say this point right here, where do they intersect? Okay. Now slopes are tricky because they always go up and down first. Y-intercepts, you need to remember, they're going to go, or what, not y-intercepts, ordered pairs are going to go across first and then up and down. And they always start at the origin. So here we're going to start at 0. We go over 2 and up 3. So this ordered pair is going to be 2, 3. Now you saw me make a mistake, and I'm like a teacher, dude. So it's always good to double check. Okay? So what I'm going to do is I'm going to plug the x number and the y number into both of these equations one at a time. So 3 equals 3 times 2 minus 3. 3 times 2 is 6, and then 6 minus 3, is 3. So that's good. That ordered pair does work with that equation there. And it wouldn't have if I had, followed up with my mistake. And that would be a good clue that I did my graph wrong. I got to go back and fix it. Okay, so here we're going to do 3 equals 1/2 times 2 plus 2. Don't be intimidated by this. Use your calculator if you need to. But 1/2 times 2 is just 1. Okay, let me show you over here why that is. Remember, when we multiply fractions, we just multiply across, and it's always good to put the invisible numbers there if there is one. 1 times 2 equals 2, and 2 times 1 equals 2. Oh my gosh, it's so early, you have no idea. And then 2 divided by 2 equals 1. Okay, but again, you're welcome to use a calculator. That doesn't bother me one bit. 1, and then we have plus 2. And it is true that 1 plus 2 equals 3. So that ordered pair did work in that one as well. Alright, I'm going to go ahead and skip 4 and 5, let you guys do those ones. And we're going to go ahead and work on question 6. I'm going to make this one be our red line. This one right here be our green line. So for the red line, I'm starting at -4. And remember that -3 over 2, where the negative is, let me write that better, right here in the middle. That could either be written as -3 over +2, or it could be written as a +3 over -2. Doesn't matter, okay? I'll leave it like that because that's how I wrote it. So, to find my next point, that means I need to go up 3 and to the left 2. Up 3 to the left 2. Up 3 to the left 2. Up 3 to the left 2. And here's our line like that. Alright, let's go ahead and do the green line. So for the green line, we start at 4, +4, and we go up 1 over 2, up 1 over 2. And to continue, we want to, that's up 1 over 2. We want to go down 1 and back 2, down 1 and back 2, down 1 and back 2, just like that. Okay, so we need to write where they intersect. Notice I'm a little sloppy, so it's going to be extra important that I check my work. And ordered pairs. Remember, we got to figure out the across number from the origin first, then the up and down number from the origin. So from the origin, we're going to go to the left 1, 2, 3, 4, and up 2. Since we went to the left 4, it's going to be -4, and then up 2. Okay, but again, I'm going to take a minute and double check my work. Where can I do that? I'll do that up here. Let me erase some of this flahooey. Okay, so here's my x and my y. So I'm going to go ahead and plug a 2 into that first equation for the y. -3/2 times -4 minus 4. Now again, use your calculator if you need to, but -3/2 times negative 4 is positive 6. And positive 6 minus 4 is 2. So that did work with this equation here. Let's go ahead and check with the other equation. 2 equals 1/2 times negative 4 plus 4. 1/2 times negative 4 is going to be negative 2. And negative 2 plus 4 is going to equal 2. We got the same thing on both sides again, so that is stellar. Alright, let's go on to the next page. Alrighty. Ooh, level 3. This looks tough, but it also looks like Mr. Morell is pretty amazing and gave you a lot of helps. So I would start solving these, and if you come across something you don't understand, chances are I've covered it right here, because I know that these can be really tricky and confusing. So here we go. Think the only one I'm going to do on this level 3 is going to be question 10. Okay, so let me come down to question 10. Oh man, you're going to be happy I did question 10 because it looks really difficult. Well, question 10, we want to graph this, but we're only used to graphing equations that look like y equals. So we need to solve for y. It looks like we're going to need to use the box of doom. Let me go ahead up here. Oh no, I have space to work down here. Okay, so box of doom. I'm solving for y so that I can graph it. So I want to say what's happening to y. Y is being multiplied by negative 4. That's the closest thing to it. And then added by 2x. Okay? Now, it is harder for me to write on the iPad than I think it is for you on your paper, but use some scratch paper if you need to. That's not a big deal. And, excuse me, I've got the burps and the hiccups. It doesn't matter. You don't care what kind of things I have got going on in my life. Alright, so we need to do the opposite stuff backwards. The first thing I'm going to do with this equation, I'm going to write it up here. 4y plus 2x equals negative 16 is I'm going to subtract 2x from both sides. Now there's no x here with the 16, so I need to write it to the side. So I'm going to have negative 4y plus, or equals negative 16 minus 2, oh my gosh, what is wrong with me? Minus 2x. That took care of that step there. And our next step is we need to divide by negative 4. And so we're going to divide all of these terms by negative 4. Ooh, it looks like it might be helpful to change that to say plus negative 2x for a minute. So that's going to leave us with y equals, let's see, negative 16 divided by negative 4 is a positive 4. And then a negative 2x divided by a negative 4 is going to be 1/2 x. But we need it in slope-intercept form. Let's go ahead and switch those. So y equals 1/2 x plus 4. Let me go ahead and graph that really fast. And apparently I'm doing that in green. So 1/2 x plus 4. We're going to go up to 4. And then 1/2 is up 1 over 2, up 1 over 2, down 1 back 2, down 1 back 2. Like that. Whew. Okay, let me go ahead and erase this work. And red, let me rewrite that over here. 2y minus x equals 8. Let me go ahead and reset this box. So in this example, y is being multiplied by 2 and subtracted by x. Let's do the opposite stuff backwards. I'm going to go ahead and add x to both sides, and I'm going to put it on the side over here because that 8 didn't have an x with it. So 2y equals 8 plus x. And then we want to divide all of the terms by 2. So divide by 2, divide by 2, divide by 2. Might be helpful to remember that invisible 1 right there. Okay, so then we're going to have y equals 8 divided by 2 is 4. And then 1x divided by 2 is the same as 1/2 x. Okay, it's just like that invisible 1 gave x the boot. And then we need to switch those around. So y equals 1/2 x plus 4. Just like that. Okay, let me go ahead and graph that in red. I'm going to go ahead and start at 4. Oh my gosh, why did I do that? 4. And then I need to go up 1 and over 2, up 1. Oh, wait a second. I'm confused. Huh. This is the exact same line that we had before. Well, let's go up and see what that box says. Right here. 2 lines that are actually the same line. These equations are always intersecting and therefore have infinite solutions. Okay, so this has infinite solutions. But what does that mean? Well, let me tell you what that means. We're going to look and see where these intersect. Well, you can see there's like an infinite number of places where these 2 lines intersect. So I could pick any one of these dots. Might be easy to pick a nice dot. So like, I don't know. What if we pick this dot right here? Okay, that ordered pair is negative 6, 1. In theory, if I plug negative 6, 1 into both of these equations, it should work out nicely for us. You don't need to do this on your work, but I'm just trying to help you understand what in the world we're saying when we say infinite solutions. Okay, so here's my x and my y. So let's see, we've got negative 4 times 1 plus 2 times negative 6. And in theory, that should equal negative 16. Oh my gosh, I'll write it better in a second. Negative 4 times 1 is negative 4. Plus 2 times negative 6 is negative 12 equals negative 16. And negative 4 plus negative 12 does equal negative 16. Okay, so for sure, that is one example of an ordered pair that works with that equation there. Let's double check it with the second equation just for fun. And yes, it is so much fun. Okay, so negative 6, 1, we've got 2 times 1 minus, in parentheses, negative 6 needs to equal 8. Well, 2 times 1 is 2 minus negative 6. Does that equal 8? Well, remember we can keep the 2, change the subtraction, and change the sign of our number. So 2 plus 6, well, that does equal 8. Holy cow. So that is 1, and I'm telling you, for any single one of these dark blue dots that I'm putting on here, any of those ordered pairs would work in both of those equations. So there's an infinite number of ordered pairs that would work. Alright, then you've got this amazing level 4 question. Oh, this is not helpful here. That was for up there. So yeah, good luck with that level 4 question, and I'll see you on our next video where we're going to learn how to do this without a graph. We're going to do this using substitution. Alright, I'll see you then.